So we are talking about the process of giving one object a net charge without touching the object to a second charged object. It is called charging by induction. Okay, so we understood two ways until now: charging by contact and charging by induction. Now, in this process, you might want to notice here the process could also be used to give the sphere a negative charge, a net negative charge. Okay, so you can replace your ebonite rod with a rod which is carrying a lot of positive charge, and you can go ahead and follow the procedure, and then you can put net negative charge on the metallic sphere. Then electrons would be drawn up from the ground through a grounding wire and onto the sphere. Okay. Now moving on, here are a few practice questions. Okay, you can feel free to try them. This is a multiple choice question. Question number 4. Question number 5. It's a critical thinking question. And similarly, question number 6 is a multiple choice question. We will be discussing them in the class. And also, I can leave the answers in the comment section. Now, let's move to the next topic. A very important topic in your electrical fields concept is your Coulomb's law. Okay, so this is a law that will discuss that if there are 2 point charges, okay, then what will they do? Okay, if they are in a distance that is relatively not too much big. Okay, so they will be exerting force on each other. Okay, we call that force as electrostatic force. Okay, so this point charge q1 will be exerting the force on this one, and similarly this q2 charge will also be exerting force on the charge q1, right? And it has been observed that the force is directly proportional to the magnitude of the charges. Okay, let's say it's 10, this is 10, then the force will be, let's say, just giving you an idea, 100, and let's say this is 100 and 100, then force will become like this. It will increase, right? So that means force is directly proportional to the magnitude of the charges. Okay, how much is the number? And then it is inversely proportional to the distance between them. If they are separated by a large distance, and the force will be less. And if they're relatively close to each other, okay, and in this case, the force will be more. I hope it makes sense. And then you have to take care of this proportionality constant. So whenever we have proportionality, right, let's say like this, you might want to put some magnitude signs. Okay, because here in the charges they can be negative as well, so these magnitude signs are important over here. And whenever you get rid of this proportionality constant, you get your proportionality constant, which would be k. Okay, that would be k, and its value is 8.99 into 10 to the power 9. Okay, you can isolate k and solve for the units of the k. Because force will be newtons, these will be coulombs, so they will multiply coulomb square and this will be meter square, and then you can rearrange to find the units of k. Okay, so electrical force is directed along the line joining the charges. So because force is a vector quantity, we are just not interested in the number, let's say 100,000 or something like that. We are also interested in knowing the direction. So where will be the force directed? So along the line joining the charges. Okay. It is attractive if the charges are unlike. If this is positive and this is negative, then the force will be attractive. Okay, and however, if it is the same charges, negative negative, or let's say positive positive, the force will be repulsive in nature. Okay, now let me get rid of all of these, hoping everything is making sense so far. Now let me give you an example. Okay, so let's say you have a question on exam where your teacher gives you q1 is minus 5 into 10 to the power minus 6. and Q2 is 7 into 10 to the power minus 6. Okay, then what does this mean? Okay, putting this Q1 in these lines, which we call as more magnitude. Uh, when you put this negative sign in between these lines, the answer that comes out is positive. Okay, anything that goes negative inside, that will come out as positive. Okay, you will not write negative. And let's say you have your positive 7.0 into 10 to the power minus 6 that goes inside these lines. So positive will stay positive, negative will become positive. Make sense? So everything will come out positive. This is how you can take care of this thing. Moving on, here is an example for you to try. Feel free to pause the video, spend some time getting your hands around this one. You are given two charges, 1 and minus 1 coulomb. The separation distance is given 1 kilometer. Okay, then you have to find the attractive force, the magnitude of that attractive force. Okay, I hope you tried this one by pausing the video, and then here's a quick solution for you. Okay, as we already discussed, the minus sign, because they're going inside the magnitude brackets, it will turn out to be positive. You have your k value, you have your r value. This should be your answer. Okay, now I hope it is making sense. Let's move forward. There's another example. Let's say you have a Bohr model of hydrogen atom. The electron, it is carrying the charge minus e. It is in the circular orbit, obviously, right? And it is moving around the proton. The proton is carrying plus e charge, and the radius is 5.29 into 10 to the power minus 11. This r value is given to you. So here's a figure that is showing you the scenario. The mass is given for the electron, and then you have to determine speed. Okay, now how we really go into this one? We have to determine the speed of the electron. Now, if you recall from your prior knowledge about the force that is acting on a that is acting on an object that is moving in a circular motion, can you recall that? So what would be the force? That would be the centripetal force. There is a reasoning that has been written for you. Feel free to pause the video and go over it. This is for your convenience and understanding what's going on over here. If it is you want to go into details. So this is a centripetal force that is acting on an object that is moving in a circular path, like our electron in this scenario. Okay. Now, what is my unknown? What I'm looking for is V. Mass is given to me, if you remember. So whenever I'm solving the question, I like to break down the information in two pieces that is given. So what is given to me? This is V, and then R is given to me as well. Some values which we will see later on. We will plug in the values in these blanks. And then force is not given to me. Okay, if force is there, then I can go ahead and find V, which is the question. Now the thing is, how do we find F, the force? Looking at the situation, there's electron and then there is also proton. I see this situation is like the Coulomb's law. I can apply Coulomb's law to find the force because these are 2 point charges, right? And they're separated by some distance. I can, easily go ahead and apply Coulomb's law, which looks like this, and then I can find the value for F, and then that value of F can be used over here to find the value of V. Feel free to pause the video and try it on your own, and I hope you did that. And here's a quick overview of the solution. So here's a breakdown of what's given and what's unknown, and here are steps towards solving it. So step one involves figuring out or isolating V. So we said F is equal to mv square upon r. So because I'm looking for V, I need to isolate it. I am isolating V. Let's say F can go on this side, and then M can also go on this side, and V is square root of F dot R upon M. Okay. So now you just need to do F. Okay, you need to do just you need to find the value of F. And what is F? Can I write over here that F is equal to KQ1, and Q1 is your electron, let's say, minus E. This is minus E. I'm sorry, by the way, for my handwriting, if it is not really readable. And this is your proton, which would be plus E, right? And then you have R square over here. So you can feel free to solve it over here only, okay? And then plug this value over here. What they did over here is that we just plugged in the formula over here, right? And make some simplified this equation, right? So yeah, feel free to do that. Then plug in over here, whichever way is fine. Everything, both ways are correct. Okay. So this should be a final answer, 2.19 into 10 to the power 6 meters per second. Now we will be covering this topic for the next video. I want to keep it short, this one. And this will be a topic for another video, which is the force on a point charge due to two or more other point charges. Okay, goodbye everyone. Thanks for watching.